of you. I hope guys audio video is clear to you. So here in this series we already started the GET questions, previous year GET questions of engineering mathematics. We had a discussion on till now so many questions of GET 2023, 2022. So here also, and first of all we will have discussion on the few questions more based on the GET 2022 which are from the EC and the computer science branch, and then we will start here the 2021 questions from the branch wise again. So if the audio video is clear guys, please confirm. All right. Is it clear? Yes. Okay, clear. All right, so let's start with this question. All right, let's start the session with this question. We are having a question which is from the EC 2022, and the question is talking about the function fx is equals to 8 log of x to the base e minus x square plus 3 attains its minimum over the interval 1 to e at x is equals to what? So we need to find out the point at which the given function having minima or minimum value in the given interval. So clearly we can see this question is from the global minima. Let's approach the question directly. So how I will approach? Let's have a discussion. So here I can see what is given to me. The function is 8 log of x to the base e minus x square plus 3. As we need to approach here the minima, so dear students, here we will approach with the first order derivative. So first of all I will find out here f dash x. When we will go with the f dash x, this is 8 by x minus 2x plus 0. Now we need to put it equals to 0 because we need to find out the roots. So when I will put it equals to 0, I am having 8 minus 2x square divided by x is equals to 0. I can see this x is already gone, so 8 is equals to 2x square. You can write down the value x square is equals to 4, which is giving you x is equals to plus minus 2. Okay, we are having a range from 1 to e. If I will talk about x is equals to minus 2, this will not exist in the range 1 to e, so we will not consider this one. Directly we will talk about x is equals to 2 here. So at x is equals to 2 I will check, because this is the question from the global minima. So what we need to do in this case or in this pattern of question, first of all we need to check the first order derivative, we need to check the point, and whatever the point or root you are having, you need to check whether this point or root is in this given range or interval or not. So here I can see my point x is equals to 2 is in the interval, so I am okay with that one. Now what I will do, I will check at x is equals to 2 what we are having, whether we are having minima or maxima. So what we will do, we will go with the double order derivative. So 8 by x we are having, so we need to go with the double order derivative, which is minus 8 by x square minus 2. And here when I will put the point x is equals to 2, here it is giving me the negative value. Negative means less than 0. Whenever we are having double order derivative less than 0, so the clearly indication, it gives you the clear indication that this is the case of the maxima. So here I can see this is the case of maxima, but in the question it is not asking me about the maxima, so I will not talk about the maxima. So it's clearly mentioned that when we are having maxima, we will not talk about this one. So what we will do in this case, so now we are having a range which is 1 to e and the value of function. value of function is 8 log of x with base e minus x square plus 3. So here we will check the value of this function at x is equals to e, 1 and x is equals to e. Among any of these, whatever is minimum, I will consider that result as a global minima. So here at x is equals to e, I need to put here the value. When I will put here, this will be 8 log 1. Log 1 is 0 minus 1 plus 3. So it is giving you the result as 2. And when you will put here x is equals to e, so this is 8 log of e to the base e minus e square plus 3. As log e to the base e is 1, so it will be, here we are having 8 minus e square plus 3. I can see when I am having 8 plus 3, 8 plus 3 is 11, and when you will put the value of e square also, when you will put the value of e square, still it will be greater than 2. So we will not consider this one because this is greater than 2. Directly we can see that this is the minimum value among the available options or among the available range. So we are having a range 1 to e at the initial and the final end. I can see the minimum value I am having at the initial end. So this is the minimum value of the function or the global minimum value of the function. But question is asking me at which point you are having minimum value. So you can directly write down at x is equals to 1, we are having global minimum value. So here as we are having options, so we will consider the correct answer as option B for Bombay. This is the final answer. I hope this is clear to everyone. Yeah, no, this is not 2. This is not 2, beta. The value is 2. This is the value of the function is 2 definitely. And here we are having, if you will solve, it will be around 3.61, which is greater than definitely 2. Okay, so it will be, we need to find out here the minimum value. So the minimum value will be, we are having minimum value at x is equals to 1. Very easily, very simply we can approach it. Alright guys. Yes. If yes, then you can reply with the yes. Alright. Now let's go with the next question. What we are having? Let's approach the next question. Let's read out the question. This question is from EC 2022 linear algebra. This is again a good question. Consider a 3x3 matrix A whose ijth element are given as aij equals to I minus j whole cube. So if we need to find out the matrix 3x3 matrix element, we can find out through this pattern, which is I minus j whole cube. Then the matrix A will be. So here if you want to make the matrix, you can directly make the matrix also. So let me write down here. This is very simple question. We can write down the matrix A as we want to make a 3x3 matrix. So if I want to find out, as my elements will be A11, A12, A22 like this, A13, then you can go with the, here if you want you can find out every element, and then you can go with the A21, okay, A22, A23, and then you can go with the A31, A32, A33. But better I will suggest you here to go with first of all the principal diagonal elements A11, A22 and A33. I will suggest you to go from this one. So why? Because in the option we are having skew symmetric also, in the option we are having null also. So if it is 0, then we can have one direction ki yeah, the matrix can be skew symmetric, matrix can be null. So for that, suppose I want to find out the A11. So A11 will be nothing but 1 minus 1, 0, right? If I want to find out A22, I need to put here na. So 2 minus 2, that is 0. 3, 3, that is 3 minus 3, 0. So I can see my principal diagonal elements are clearly here 0, right? Okay. So if the principal at 0, so you can see this is not symmetric and this is not unitary. So these two options are already gone. Now if it is skew symmetric, so we should have the mirror image around the principal diagonal with the opposite sign. So in that case, I will suggest you to go with A12 and opposite of this one, that is A21, any two elements. If I will go with the A12, this is 1 minus 2, which is minus 1 whole cube is minus 1. If I will go with the A21, that is 2 minus 1, I need to put here 2 minus 1, that is 1 only. 2 minus 1 cube is 1, 2 minus 1 is 1, 1 cube is 1 only. So here I am having element, as this element will be minus 1, this element will be plus 1. So surely I am having here this skew symmetric, because if it is null matrix, then these elements must be 0. In a null matrix, we are having all elements are 0. So if this is null matrix, then every element should be 0. But here I can see A12 and A21 are same with the opposite mirror image. I can say these two elements are like this. The opposite mirror image means mirror image with the opposite sign. So I am having here 1 and minus 1. Both elements are same with the opposite mirror image. So this must be the skew symmetric. So directly you can just have a decision that this is the final answer, option B for Bombay, which is skew symmetric. I hope this is clear to everyone. Please confirm, dear students, whether it is clear to you or not. Give me confirmation, dear students, whether it is clear to you or not. Please confirm. Yes, clear? Now let's come to the next question. Okay, this is a question from the CS 2022, a simple question. Let's read it and approach it. So we are having a question from GATE 2022 CS branch. Consider the following two statements with respect to the matrices A, which is a M cross N matrix, B N cross M matrix, and C N cross N matrix, and D. So we are having four matrices. You can see A, B, C and D. Among these, A's order is M cross N, B's order is N cross M, C's order is N cross N, and here we are having again N cross N. Okay. Two statements are given to us. First statement 1 is a trace of AB. This is the sign of trace TR. Trace of matrix AB is equals to trace of BA. Second statement, trace of matrix CD is equals to trace of DC. So first of all, I know very well that the matrix multiplication is not commutative. But here, if I will talk about the AB and BC, if I will multiply here, suppose I will multiply AB. So my order will be, when I will multiply these two matrices, my order will be M cross M. Or if I will multiply BA here, if I will go with the BA, then my order will be M and M will be omitted. So here the order of the new matrix will be N cross N. So we can see we are having a square matrix in both the cases. So whatever is your result, definitely the matrix will be different, but whatever is your principal diagonal will be same. If you want to see, I am giving you one simple example. If I am having A, B, C, D, okay, if this is my result for AB, okay, if I want to get the result for the BA, so in this case it will be nothing but the flipped na. So in this case it will be A, C, B and D. Okay, so in this case, in both the cases, your principal diagonal elements will be same. In both the cases, your principal diagonal elements will be same. So when the principal diagonal element will be same, so sum of the principal diagonal element will automatically same. It means your trace is automatically same. So we are talking about the trace only, na? We are not talking about the determinant here. So the trace will be same. So either the trace of AB is equals to trace of BA. Yeah, this is the true statement. When I will go with the same thing for matrix C and D, as when we will multiply, both are having the result N cross N only. If you will go with the DC, then also it is having the order n cross n. So this is also having the principal diagonal elements will be same, hence the trace will be same. In this case also the trace will be same. So we can conclude here the result that both the statement 1 and statement number 2 are correct, as the trace of matrix AB and BA, trace of CD and DC will be same. I hope this is clear to everyone. No, this is not A, this is C here. The answer in this case is C. Clear? Alright. So my statement 1 and 2 are correct. Let's come to the next question. What we are having? This question is from GATE 2022 CS branch probability. So the number of arrangements of 6 identical balls in 3 identical bins. As it is mentioned to you, it's a very simple question. You can understand like this. You are having six identical balls. So 1, 2, 3, 4, 5 and 6. And you are having 3 boxes. So suppose this is first, this is second and this is third. And all these 3 are identical. All these 6 are identical. Okay. So what it is asking to you about that the number of arrangements. So how many possibilities are there? Number of arrangements are how many? So this is the question actually from the permutation and combination. This is the question. But here we can approach directly. Okay. Without going, we can directly count here and we can go with. As we can see here, the order means which ball I am taking, it does not make any difference. And which bin or which box I am taking, it does not make any difference, because these 3 are identical and these 6 are identical. So it does not make any difference ki you are taking which ball and you are taking which box. Okay. The only thing which matter here that how you are arranging 3 objects, because here we need to arrange 6 identical balls. We need to arrange like this. It is very clearly mentioned 6 identical balls you need to arrange in 3 bins or 3 boxes. So how you can possible, or what are the possible cases? Very easily we can write down possible cases. How we can write down? Suppose I am having 3 boxes now. So what I can do, all the 6 balls I can fill in 1 box. Okay, in the remaining 2 you can go with 0 0. So it is possible to, because it's not mentioned that what is the minimum criteria. You can start from the 0, you can go with the maximum also. So you can start, suppose in the first box I want to go with this all the 6 balls. In this first, second and third I will go with the 0 0. So this will be my first case. In the second case I can go with the, suppose here I want to go with the 5, here I want to go with the 1 and then I want to go with the 0. Or it is possible to go with the here 4, you want to go here 1 and you want to go here 1. This is also possible, because ultimately we are having how many? Ultimately we are having how many boxes? We are having 3 boxes and we are having 6 balls. So in this manner we can go with the simple arrangement. Okay. So this is possible 5 1. Okay. If you want to go with the 0, you can go with this one also 5 2 0. You can put 0 also. This case also I will write down. Okay, just hold on. So 4 2 0 is also possible here. If I want to go with the 4 1 1, I can go with this 4 1 1 also. If you want to go with this one 3 3 0, this is also possible. 3 2 1, this is also possible. Okay. If I will go with the next case, this is 3 2 1, this one is also possible. If I want to go for the next one, so this is possible to go with the 2 3 and 1. This is also possible. 2 3 no, 2 3 and 1 will be we already had a discussion. So 3 3 3 2 1 2 3 1 is same. So we can go with the 2 2 2, because here 2 3 1 or 3 2 1 is same. We can go here with the 2 2 2. So how we can see that we need to arrange ultimately 6 balls in 3 boxes, and all the 6 balls are identical, all the 3 boxes are identical. So you can start with 6 0 0. You can go with 5 1 0, means here I am putting 0. 4 2 0. Okay, I can go with 4 1 1. I can go with 3 3 0. I can go with 3 to 1, I can go with 2 to 2. So these are the 7 possible cases. As it is asking about the number of arrangement, so I can write down how many arrangement are possible. These are the 7 possible cases for us in this pattern of question. I hope this is clear to everyone. Clear? बेटा the order can be same. It's not written कि matrix same है. Order suppose I'm having 3 matrices of 2 cross 2 2 cross 2 2 cross 2 तो हो सकता है ना. It's not mentioned कि matrix same to same है. वहाँ order लिखा है. I hope you are getting my point. It's mentioned order, not the matrix. Clear? Please confirm everyone. Yes. Okay. Now you guys will try this question. This is a good question from the limits. You should try this question. Everybody should try this question. Everyone should try this question. Go for it. Yes, dear students, what is the result according to you? let's have a discussion. So this is the, anyone is there with the reply? No. Let me check. No one is replying. All right, let's go with the solution. So here first of all we can see this question is from the limits calculus CS 2022 question. The value of the limit is, we need to find out the value of this limit when the question is limit extends to 0, root of x by 1 minus e to the power twice root of x. So we will write down the question what is given to us. First of all, as it is given to us, the value of the function means the limit extends to 0, 0 plus means the 0 only, root x by 1 minus e to the power 2 root x. Now what we will do? Here we can see when I will put here x is equals to 0, this will be 0, this will be 1 minus e power 0 is 1. So this is nothing but a 0 by 0 form. And whenever we are having 0 by 0 form, we need to use the L'Hospital rule. So I will go here with the L'Hospital rule. When I will go with the L'Hospital, dear students, directly we need to differentiate numerator separately and denominator separately. So when I will go with the differentiation of this root x, this will be 1 upon 2 root x. Divided by differentiation of 1 is 0, so this is minus e to the power 2 root x, and when I will go with this one again, so this is 2 by 2 root x. 2 and 2 will be gone here. So when you will approach again the limit, because you need to ultimately put the limit, so when you will put here the limit, okay, this is the negative one, we are having this one is a negative. So when I will put the value again, this will be 1 minus 2, because root x will be gone in this case. When you will put here the limit, so you are having 1 upon 2 e power 0 is 1 only. So this is directly you can write down minus 1 upon 2 as this is a numerical answer type question. So you need to write down the result in the decimal. So the result is 0.5 with the negative sign. Your final answer will be 0.5 with the negative sign. Very easily we can approach it. No, this is not 1 beta. We are having 1 by 2. We are having 1 by 2 here. So after approaching the limit, it is, yeah. All right, clear? So I hope the question is clear to everyone. Yeah, so if you are there, dear students, if you are watching this session either in the live or in the recording, so you should reply, okay, after the class also you can reply in the comment box ki is it the clear, the questions are clear to you or not. And if you are attending the session in the live, then you should reply in the live chat box. I can see the number of students are live more, but as the only 2-3 guys are replying here, so you should reply, everybody should reply here. All right. Let's go with the next question. This question is from IN 2022 and this is a MSQ multiple select question from the linear algebra. Let's see the question. Given the matrix M is equals to 2, 3, 7, 6, 4, 7, 4, 6, 14. Which of the following statement is or are correct? The rank of M is 2, rank of M is 3, rows of M are linearly independent and determinant of M is 0. So ultimately, first of all, we need to find out here the determinant, okay, and on the determinant it depends the rank, and when the rank you can identify whether it is 2 or 3, so you can very easily identify here all the rows are linearly independent or not. So let's approach it. So I will write down the matrix. Directly I am approaching the matrix. Given the matrix M is equals to 2, 3, 7. Next is 6, 4, 7. And the next is 4, 6 and 14. We are having this one. What we can do very easily, we can see that the first row is 2, 3, 7. If from the third row, if I will take 2 outside, look at here, very easily we can approach. If from the third row I will take 2 outside, this will be 2, 2 ja 4, 2, 3 ja 6, 2 7 ja 14. So first and third row are identical, and whenever in a matrix any two rows or columns are identical, directly we can put the determinant is equals to shunya. So in this case I can write down the determinant of matrix M is equals to 0. When the determinant of a 3 cross 3 matrix, look at the order here. If you will approach here, it is giving you the sense that the rank will be less than is equals to 3. But once you are having that the rank of M, so once you are having that the determinant of M is 0 for the 3 cross 3 matrix, if the determinant of M is 0, so directly we can write down the rank will be now less than 3. So you can write down that the rank is less than 3. When it is less than 3, so we can go with the 2 cross 2. So I need to check whether it is 2 or 1. So what I will do, I will just check this very first minor. I will check the value of this very first minor, which is 2 4 ja 8 and 6 3 ja 18. I can see the very first 2 cross 2 minor is not equals to 0. When it is not equals to 0, so the determinant is for 2 cross 2, the minor is not equals to 0. So hence you can write down directly that the rank of this matrix M is equals to 2. So when the rank is 2, determinant is 0. Now look at the option. So we can see first of all the first option is absolutely right. The rank of the matrix M is 2. No, this is not 3. And the determinant of M is 0. Yeah, this is also true. Now it is asking about that the rows of M are linearly independent. No. Why it is not linearly independent? Because if it is linearly independent, so in this case the determinant should be not equals to 0. Whenever we are having in a matrix rows or columns are linearly independent, so in this case all the rows when linearly independent, so in this case the determinant should be non-zero, and here we are having determinant is 0, so this is not possible. So these two options will be eliminated. Hence in this case answer will be option A and D, since this is a MSQ question. So I hope this is clear to everyone. Yeah. So I hope this is clear to everyone. Very easily we can understand this one. We need to go with the rank. We need to identify the rank. So how to identify the rank? So I hope it is clear how I am identifying the rank. All right. Clear, dear students? Now let's go for the next question. Let's go for the next question. As let me correct the question. This is x cube e to the power minus mod of x. This is the question. X cube. This is not x into 3. This is x cube. X cube e to the power minus mod of x. Now let's approach this question, which is from calculus, and this question is from for IN 2022. The question is the global minimum of x cube e to the power minus mod x for x belongs to minus infinity to infinity in the open interval occurs at x. So here we need to find out the point at which the function is having global minima. Alright, it's not asking about the global minimum value of the function, it is asking about the global minima only. So how we can approach? So first of all we can consider that the given function is x cube e to the power minus mod of x. This is the function. As it is given to us that the range is minus infinity to infinity, so and e to the power mod x. So what we can do, we can start doing for the two cases. So let's start with the first case. I start with the for x is less than 0. If I will start from the x less than 0, and here in this case if I will have the global minima, then I will stop here only. Or if in this case I will have the global maxima or point of inflection, then I will check for the x greater than 0 also. So right now I am going with the x less than 0. So this will be x cube e to the power minus minus plus, because when I will go with the value of mod x when it is less than 0, so it should be minus x, so minus minus plus x. So here this is the value of function. We need to find out the first order derivative, means the dy by dx you can say. So this will be 3, okay, first I am going with the x cube. So this will be 3x square e to the power x as it is, plus this is x cube and here e to the power x. You can take common in this case x square e power x. You are having 3 plus x. And what we need to do, we need to find out the root. So we will put it equals to 0. So let's put f dash x is equals to 0. When we will put f dash x is equals to 0, it is giving you x square e to the power x. X plus 3 is equals to 0. So from here we are having 2 points. The first point is x is equals to 0. And the another point is when I will put this one, so this is x is equals to minus 3. So we are having 2 points, x is equals to 0 and x is equals to minus 3. Alright. So as x square e power x will be 0, so x is 0. So what we need to do, we need to check the double order derivative f double dash x. Let's find out the double order derivative of this one. So for x square e power x, or if you don't want, then you can go with this also. So let's go from this one. So let me write down f dash x is here 3x square e to the power x plus x cube e to the power x. I need to find out the double order derivative. When I will go with the double order derivative, so this will be 3 to just 6x e power x as it is. This will be 3x square as it is. Differentiation of e power x is e power x only, plus this is x cube is 3x square and e power x as it is, plus x cube is as it is and e power x. So I can see we can go with some repeated values. So this is 3x square, we are having 6x square. So 6x e power x plus 6x square e power x plus x cube e to the power x. Okay. So when you will check it, f double dash x, this is the value of double order derivative we are having right now. This is the value of double order derivative we are having. So 6x e power x, 3x square, and this let it be as it is. Okay, now what I need to do, I can see here, first of all I am having 2 points, x is equals to 0. So first of all you can see at x is equals to 0, the triple order derivative becoming 0. So it cannot give you the minima. Okay, when you will put at x is equals to 0, you are having double order derivative is 0. When it is 0, we need to check the triple order derivative, and triple order derivative, okay, is not equals to 0. So at x is equals to 0, so we are having point of inflection. So we will not talk about this point of inflection, because in the question I need to identify the global minima. So what I will do, now I will check at the point x is equals to minus 3. When I will put here x is equals to minus 3, so this will be 6 into 3. So this will be minus 6 e to the power minus 3, plus this is 6 into 9. So you can go with the 6 into 9 e to the power minus 3, plus the next is again minus 27 and e to the power minus 3. So when we will put and when we will check the values here, after checking the value, let me check also here. So after checking the values, I can see this will give me 27 I am having as a positive. So this will give me, this is negative. Yeah, this is negative. This is positive. This is negative. So we are having ultimately the value is 9 e to the power, and whatever it is, I can see the value is a negative value. No, it should be positive. When I will check here, so x cube we are having, okay, e power x we are having, x cube e power x, 3x square e power x we are having, okay, that is the only. All right. So 3 and this is 3 and this is 3. So this is the 6. This is okay, absolutely right, perfectly right. Here we can go with x cube x square e power minus 3. So this will be okay. So when I will go with this one, so if I will put here the value, so this will be negative, but e to the power whatever it is, here we are having the value as a 9 e to the power minus 3, and when you will check here now, this will give you the positive root. So whenever you will approach directly, you can check, and when you will check, it will give you the positive root. Positive root means the greater than 0. So the value of the function at x is equals to minus 3, double order derivative will be greater than 0. So hence we can say it's having minima. We can say it is having minima. Okay, you can check the values by putting the values directly, you can see, and it is giving you the minima. Okay, right? Because this is a positive number now, so minus 27 and 6 if I will add, but still I am having here 9 6 are 54, so this is a positive number, so I am having a positive value, so 9 e power minus 3 something I am having, so this is a positive root. So clearly I can see that the result 36, 54 minus 36 is 9, okay, and no 9 whatever it is, but it is here we are having e power minus 3, so e power minus 3 when you will multiply this one, so this is a positive root you are having. So you can see that this is the minima value. Minima we are having at which point? So we are having minima at x is equals to what? Minus 3. So I can conclude I am having minima at x is equals to minus 3. Now what the question is asking to me? Question is asking to me the same thing na, ki I need to find out the global I need to find out the minimum value of the function at which point it is having minimum. So you can write down you are having at x is equals to minus 3 the minimum value. So this is the final answer. I hope this is clear to everyone. Yes. So when I will calculate, I can see that I am having the, when I will calculate, I can see I am having the positive root in this case. 9 e to the power minus 3, because we are having one as a minus 27, this is minus 27 minus 6 minus, and here we will go with this one. So this is a positive root we are having. I think this is 6 3, it should be 18. It should be 18 because I am having here x also na. So it should be 18 minus 18, right? So now this will be 45, 54 and 45. So this will be when I will put here x is equals to minus 3. So it will be minus 27 minus 18. So this is minus 45 and here we are having 54. So this will be a plus. So you can just check here that f double dash minus 3 will be 9 e to the power minus 3. So 54 minus 45 is 9, 9 e power minus 3, which is a positive value which we can directly approach as a minima, because if the double order derivative is positive your result is minima, hence you are having minima at x is equals to minus 3. Yes, clear everyone? Do reply. I hope this is clear to everyone. All right, now let's go with the next question, which is for the Newton-Raphson. Let's go with the next question, which is from the Newton-Raphson. Okay, let's read the question. This question is from IN 2022 Newton-Raphson numerical methods. So the Newton-Raphson method is applied to determine the solution of fx is equals to 0, where fx is equals to x minus cos x if the initial guess of the solution is 0, as it is given to us the initial value or the initial root is 0. So the value of the next approximation we need to find out here x1 up to the 2 decimal places. Let's approach it. First of all, I need to use here the Newton-Raphson. So we know very well the Newton-Raphson is xn plus 1 is equals to xn minus function of xn by f dash of xn. So if you want to find out here the x1, it should be x0 minus function 0 by f dash derivative of the function at x is equals to x0, right? This should be your root for the x1. Okay, we are having the function now. What is given to us? We will use that function. So given the function fx is equals to x minus cos x. The function fx is equals to x minus cos x. We will go, we need the derivative also. So we will go with the f dash x. F dash x, the differentiation of x is 1. Differentiation of cos x is minus minus plus sin x we are having. Okay. So now when we will approach it, we can see we need to put here the value. So x1, when I will go here with the x1, x is 0 as the initial root is 0, so this will be 0, minus when I will put here the 0, so this is 0 minus cos 0, cos 0 is 1, so you can go here with the 1. Okay, here you can go with the 1, or you can write down this as a 0 minus 1 divided by here in the f dash, in the derivative here we are having what it is, sin 0. When you will put this is 0, so here you are having 1 again. So when you will when you will approach it to here, you can see this is the, in the denominator we are having 1, so this is x1 is equals to minus minus plus 1 by 1, which is equals to 1. So very easily we can see that my first approximation when the initial root is 0 means the x0 is 0. So your first approximation x1 will be 1 by the Newton-Raphson method. You can write down directly the answer as here 1, because this is a numerical answer type question and very easily we can approach it. Yeah, very good. The result is 1. I hope the question is clear to everyone. Yes. Clear everyone? All right, now let's go with the next question. We are having the question from IN 2022 probability. A box contains 6 red balls and 4 blue balls. If 3 balls are drawn in succession without replacement, as it is clearly mentioned that you need to draw one by one and the replacement is not allowed in this case. So the probability that the second and the third ball drawn are red. So a very good question we are having. Second and third you want as a red. So first can be anything. So let's approach. So here we are having a box. Very simply we can approach this question. In the box we are having 6 red balls and 4 blue balls. So 6 are red and 4 are blue as it is mentioned. You need to draw the 3 balls. So you will draw 1 and then the second and then the third. As it is mentioned to us that we cannot put back again. So whatever the ball you will take first outside, so you cannot replace the ball again in this box. It is clearly mentioned. Okay. So now we need to find out that what is the requirement. The requirement is if you will draw the 3 balls. It's very simple. If you will draw the 3 balls, so this is very simple and you can approach like this one. If you will draw the 3 balls, so at the second and third position you want red ball. In this case also you want at the second and third position we want red ball. These are my possible cases. These are the possible cases that at the second and third position we want only and only red ball. Okay. Now what about the first one? This is the important part here. What about the first one? The first one can be blue or first one can be red. So here we can write down the first one can be blue and the first one can be red, as it is not mentioned that on the first ball, okay, or at the first draw red ball cannot possible. It is mentioned that when you are drawing the 3 ball, when you are taking outside the 3 balls, so out of those 3 balls at the second and third position you want red. So it is possible that the first position can have blue ball or first position can have red ball. So this is very crystal clear in your mind also, guys. Okay, so we need to approach like this one. So we will go with the probabilities. So if this is my first one, this is my first one. If I will go with the required probability in this case, in the first case, if I will go with the required probability, so probability of getting 1 blue ball. So as I can see, I'm having 4 blue balls. If I want that this first one will be blue, so my probability for the blue ball will be 4 out of the 10 balls, because the total are 10 here. Okay. If you want to draw, because as the replacement is not allowed. Now in the second you want a red ball. So in the second when you want a red ball, so it will be, we are having 6 red ball. Overall in the box we are having how many balls now? We are having now only 9 balls, because 1 is already taken. So we can go with 6 by 9 for the second red ball. If we want to go for the third red ball, so for the third red ball we are having how many red balls? Earlier 6, but now in the box we are having only 5 red balls. So what we can do, we can write down here 5, and in the box earlier 10 balls were there. Once you draw 1, so now that the 9 was there, and now we can see 2 balls are already drawn, so it will be 8 balls. So this is 4 by 10 into 6 by 9 into 5 by 8. When I will go here with the probability, so in this second case what should be the probability? When you are drawing with first, second and third, all the 3 balls are red here. So you can go with the first case is 6 by 10. second is you are having now one you already taken out, so now we are having only 5 red balls, so this will be 5 by 9. Okay, so now this will be what, 5 by 9. And when we want to go with one more red ball, so we are having how many, now we are having only 4, so this will be 4 by 8. Okay, so 6 5 9 6 5 4 10 9 8. So we can solve very easily this case. So 5 2 ja 10, 4 2 ja, and 2 time and 3 time, 2 and 2 will be gone. So from here I am having 1 by 6. If I will solve this one, 5 2 ja 10, 4 2 ja, 2 time and 3 times, so 2 and 2 will be gone. So again I am having from this side also 1 by 6. So my required total probability will be 1 by 6 plus 1 by 6, as it is 2 by 6. So my result is 1 by 3. We don't have options here. This is a numerical answer type question. So 1 by 3 will be 0.333. If you want up to the 3 decimal places, you can write down the result as 0.333. If you want 2 decimal places, so your result will be 0.33. This should be your answer. Very easily with the basic concept of probability we can solve this question. Yes, bachcho, tell me, is it clear or not? Clear? Everyone? I hope this is clear to everyone. Yeah, you guys are not replying in the comment box. You should reply. Okay? So if anyone is there, you should reply in the comment box also ki you are getting my point or not. Alright, now let's go with the next question. What we are having, let's have an approach. This question is from GATE 2021 mechanical branch, and the question is from linear algebra. The question is, consider a vector P in two-dimensional space. Let's its direction counterclockwise angle with the positive x-axis be theta. Let P be an eigenvector of a 2 cross 2 matrix A with corresponding eigenvalue lambda. So for this matrix we are having eigenvector as x and the eigenvalue is lambda, where lambda is greater than 0, so eigenvalue is positive. If we denote the magnitude of a vector V by this one, so this is the sign of magnitude, okay, or you can write down as a norm also, by this one. So the valid statement regarding P dash, where P dash is equals to AP, it is given to us. We need to check the statement with respect to P dash, and when it is given to you P dash is equals to AP. So let's start from this statement. As I can see, P is a two-dimensional matrix first of all, and when the P is a 2D matrix, I can very easily understand it's okay, P is a vector, so P is an eigenvector of the matrix A. So can I write down directly here that AX is equals to lambda P, because, or AX is equals to lambda P, or AP is equals to, better to write down X, not better to write down AP is equals to lambda P. Why? Because for the matrix A, we know very well, we used to have this statement na, AX is equals to lambda X. This is the very simple technique which we use so many times in the classroom also for finding eigenvector, where X is the eigenvector, lambda is the eigenvalue. So in this case, as it is mentioned to you that P is the eigenvector and lambda is the eigenvalue only. So this is the first statement. Where I will go with the second one, but it is given to me in the case now, P dash is equals to AP. So according to me, lambda P is equals to AP, and according to the question, P dash is equals to AP. So we can go here with this technique that we, by first and second, we can write down directly when P dash is equals to AP, or P dash, so from here I can write down directly that P dash is equals to lambda P. when P dash is equals to AP and AP is equals to lambda P, so automatically my P dash is equals to lambda P. And when we are having P dash is equals to lambda P, so we can very easily understand, dear students, that in this case it is clearly mentioned that P dash is equals to lambda P. So the norm or the length of P dash is equals to, let's take the magnitude both the side. So magnitude of P dash, you can write down like this, magnitude of P dash is equals to magnitude of lambda into P. If I will take outside this one, so this will be the magnitude of P dash is equals to lambda into magnitude of P. So now what the question is asking to you, look at here, that this is giving you the clear indication. This is giving you the clear indication that the direction of this vector, because the magnitude are same, this is like the simple form. So we can conclude from here directly that the direction of P dash and P is same. Direction of P dash and P is the same. Clearly we can understand this thing from this statement. So you can see, look at the option, direction of P dash is equals to theta, means it is giving you the indication P dash is equals to lambda P. No, this is not we are having. So what we are having? We are having this one now. So you can see, okay, yeah, this is the truth. So direction of P dash is equals to theta. P dash is equals to theta. No, we don't have this statement. P dash, direction of P dash is equals to lambda theta. No. Direction of P dash is equals to lambda theta. No. So we are having this one only na, ki direction P dash is equals to, or the magnitude of P dash is equals to lambda into magnitude of P, which is giving me the indication that direction of P dash and P is same. Why? Because it is mentioned in the question na, ki direction of P is a theta. And now when I am seeing that the statement in the option A itself, that this is the statement we are having, that length of P dash is equals to lambda P. So direction of P and P dash both will be theta. So you can write down here will be theta in the option A. So the option A for Ahmedabad will be your clearly right answer. Very easily we can use here with the simple concept of eigenvector, we can approach this question. I hope this is clear to everyone. Now let's approach with the next question, which is from the, clear everyone? Let's go with the next question, which is from GATE 2021 mechanical branch. This question is from differential equation. If yx satisfy the differential equation sin x dy by dx plus y cos x is equals to 1, subject to the condition y pi by 2 is equals to pi by 2, then we need to find out the value y at y pi by 6, okay, or at pi by 6. So we can write down first of all the given equation in a systematic manner. Very easily we can solve this question. Right now the equation is sin x dy by dx plus y cos x is equals to 1. When we are looking this equation, we are not sure that what is the form. So when we are writing the equation like this, that dy by dx plus y cos x by sin x equals to 1 by, when you will put here, means what I am doing, I am just dividing every time, in every term I am dividing by the sin x. So here the sin x will be gone. So I am having very easily the remaining terms, okay. So, and if you, this is better, if you want to divide with the sin x, so it will be better for you also. So we can write down the dy by dx is equals to y, we are having as a cot x, and here we are having as a sin by sin. Oh sorry, this is my mistake, this I am having as a 1 by sin x. So 1 by sin x is cosec x, because what I am doing, I am dividing every term by the sin x. So here sin x by sin x will be gone, cos x by sin x will be cot, and 1 by sin x will be like this. So I am dividing every term by the sin x because I want to have a simple or systematic manner of the differential equation. Now when we are observing this equation, we can see this is nothing but a linear differential equation, which is of the form dy by dx plus py is equals to q, where you can see that your p is equals to cot of x, your q is equals to cosec of x, and we can go with the solution. So when we are having this one, we can write down P is equals to cot x and Q is equals to cosec x. We need to go with the first of all integrating factor, which is e to the power cot of x dx, integration cot of x dx. So when we will go with this one, the integration of cot is nothing but log of sin x. So you can write down here e to the power log of sin x, where the base is e only. So we can see the base will be gone. So directly your integrating factor will be sin x only. So this is the integrating factor. We need to find out the solution. Let's go with the general solution. So general solution will be y into integrating factor, which is sin x is equals to integration q. Q is the cosec x, multiply with the integrating factor, which is sin x dx plus c. So if you want, you can directly write down cosec x is nothing but 1 upon sin x. So this we can write down directly, and here from we can cancel out cosec x and sin x. So here we are having y sin x is equals to integration of 1 with respect to x is x only, x plus c. So this is the general solution which we are having. But we need, here it is given to us some initial conditions also, and we need to find out the value at pi by 6. So first of all, we will use these initial conditions, that at x is equals to pi by 2, it is given us the value of function is also pi by 2. So let's put here pi by 2. When I will put here pi by 2, this is pi by 2 sine of pi by 2, which is 0, equals to pi by 2 plus c. Okay, so here this is 1. I can go with the pi by 2 minus pi by 2 will be cancel out. Pi by 2 minus pi by 2 is 0. So I can write down the value of c, means the constant. Value of c means this constant will be 0 here. So we are having the value of constant is 0. We can put here the general solution y sin x is equals to x plus 0. So you can write down directly x. So this is the general solution. We need to find out the result at x is equals to pi by 6. So let's put here at x is equals to pi by 6. We need the final answer. So this is y sine of pi by 6 is equals to pi by 6. Now look at the option. Do we have options also? Yeah, we are having options. So directly we can approach. So this is nothing but sine pi by 6 is 1 by 2, and when you will solve, you can write down here. This is 1 by 2 is equals to pi by 6, 2, 3 ja. So your result will be y is equals to pi by 3. This should be the final answer, as we are having options also. So we can approach with the correct answer as option B for Bombay, pi by 3. Very easily we can approach this question. Isn't it, bachcho? Please approach. Yeah. I hope this is clear to everyone. Please confirm. Yeah, the correct answer is B. Definitely here we can see. Yes. Okay, now let's see what next we are having. Alright, so let's approach with one more question. This question is from GATE 2021 mechanical calculus question, limits question. So the value of the limit extends to 0, 1 minus cos x by x square is, we are having options also. Let's approach it directly. So I can see the function is limit extends to 0, 1 minus cos x by x square. First of all, whenever the question is from limit, we need to check whether the function is satisfying the limit or not. So what I will do, I will put here x is equals to 0 in numerator and in denominator. When I will put in the numerator, I can see this is cos 0 is 1, so 1 minus 1 is 0 divided by 0. So here we are having a 0 by 0 form. Whenever we are having a 0 by 0 form, we need to use the L'Hospital rule. So here I will go with the L'Hospital rule, so which is limit extends to 0. 1 is 0, differentiation of 1 is 0, differentiation of cos x is minus sin x divided by x square is 2x. I can see if I will put here x is equals to 0, so sin 0 is 0, and again we are having 0 by 0 form. So again this is a 0 by 0 form. We need to apply again L'Hospital rule. So when I will approach again L'Hospital rule, limit extends to 0, differentiation of sin x is cos x divided by differentiation of 2x is 2. Now when you will apply the limit here, limit extends to 0, cos 0 is 1 divided by 2. So very clearly we can see the result is 1 by 2, and here we are having options also. In the option A we can see the final answer as option A for Ahmedabad. Very easily, very simply we can solve it. Isn't it, bachon? Yes. Clear? Yes. Now let's go with the next question. So this will be the last question of today's session. In the next session we will have discussion on the more questions also. So let's see the question. This question is from the complex variable. The question is, let's see, represent the unit circle centered at the origin in the complex plane, and the complex variable z is equals to x plus iota y. The value of the contour integral close integration C cos hyperbolic 3z by 2z dz, where integration is taken counterclockwise. So as it is mentioned, we need to take the integration counterclockwise. So let's approach. So first of all we will write down the given integration as I is a closed integration C cos hyperbolic. The question is cos hyperbolic 3z by the 2z dz. So what we will do, we will find out the pole from here. So for finding pole, what we need to do, we need to put the denominator is equals to 0. So putting denominator is equals to 0, 2z is equals to 0. It is giving you z is equals to 0 as a pole. It is giving you z is equals to 0 as a pole. So when we are having a pole as z is equals to 0, we need to check. So here you can use the Cauchy's integral formula also, and if you want you can go through the residue also. So let's approach at z is equals to 0. At z is equals to 0, what we will do, just 1 minute. So here we are having the pole at z is equals to 0. We can approach the question by either the residue theorem or by the Cauchy's integral. So let's approach this question by the residue theorem. So I will find out the residue of the given function at what? At z is equals to 0. If I want to go for the z is equals to 0, it will be limit z tends to 0. Okay, and here I am having the function as z minus 0. Okay, and if you want to approach directly, we can approach it with this one. So this will be z minus 0 into your function. Function is cos hyperbolic 3z by 2 z minus 0. So we can see here the z and z will be gone in this case. We are having the remaining thing as limit z tends to 0. As we cannot approach this cos hyperbolic. So we need to use here, as we know that the cos hyperbolic x, so we will use the cos hyperbolic function in the form of the exponential, because look at the option. In the options we are not having the hyperbolic, so we need to convert this one in the exponential. So the cos hyperbolic we used to write down as e power x plus e power minus x by 2. So if I am having here, let me use the next slide. if I am having here the result as a limit z tends to 0, this is cos hyperbolic of 3z divided by 2z. Okay, sorry, that z is already gone, divided by the 2, the z is already gone. So when I will use here, so I can see that I can write down this as a e to the power 3z plus e to the power minus 3z by 2 when my limit is z tends to 0. Now I can approach here the limit, I can apply the limit directly and I can get the result. So when I will apply the limit, I can see e power 0 is 1. Okay, this is also we are having e power 0. So this is the e to the power, we are having here the, and here, okay, 1 is there and we are having 2 also. So this I need to multiply with the 2 because the result is e power x plus e power minus x by 2 na. So that we are having multiply by 2 also. So I can see when I will put here, this is 1, this is 1 divided by 4. So my result is 2 by 4. 2 by 4 means 1 by 2. As I am using here the residue theorem, so according to the residue theorem, integration of fz dz is equals to 2 pi iota into sum of the residues, sum of the all residues which are lying inside. So sum of the residues, and here we are having only one residue which is 1 by 2. So what you can do, 2 pi iota multiply with 1 by 2. 2 and 2 will be gone. Your result will be pi iota. In this case, your final answer will be pi iota, which we can see in option A for Ahmedabad. Very easily, very simply we can approach this question. I hope this is clear to everyone. Isn't it, bachcho? Please confirm. So very easily we approach the question. Now I am giving you one question as a homework. So everyone who is watching the lecture in the live, or if you are watching the lecture in the recording, you guys will try the question and you guys will write down the result in the comment box. I will check that result also for you. So my next question is this. This is the question from the differential equation. Consider the following differential equation: 1 plus y dy by dx is equals to y. The solution of the equation that satisfy the condition. So initial condition is given to you and the differential equation is given to you. You guys will try this question. Okay, whatever is your answer among the options, you will write down in the comment box what is the final answer according to you. So this is your homework type of question which you guys will try, and we will discuss the question in the next session. Okay guys, so I hope the all questions whatever we discussed today are clear to everyone. We will meet again in the next session. Till that, take care. Bye bye. Good night all of you. You can join the Telegram group of IMS Academy, which is already mentioned in the description box. So join the Telegram group and see you again on the YouTube. Till that, take care. Bye bye.